my fellow mathematicians, you are back with Miss Ledbetter, and it is time once more for some more math. Today we're just going to do a real quick overview for our laws of exponents. It's been a while since we've talked about these rules of exponents, just basic, simple, how do you add, subtract, multiply, and divide with exponents. So we're just going to do a real quick overview. Make sure that you are taking notes, and you're going to put this in your interactive notebook on page 48. For our unit 8 for our exponential functions. We have to know how to work with exponents, simplify exponents before we can actually solve equations using exponents. So just a real quick overview. All right, so here are your laws of exponents. And there's a whole bunch of letters here, so it's kind of difficult to understand. So we're going to make this a real quick, simple application. We're just going to make up some numbers. And you can make up any numbers you want. I'm just going to pick some random numbers. So let's say that A is 2, and M is 5, and N is 8. So then we're going to plug in numbers everywhere we see that these letters within each of the laws so we can kind of get a little bit more understanding of what these actually mean. Okay, so law number 1, if you have the same base being multiplied together that has two different exponents. So the same base, A is the same, but two different exponents. Anytime that I'm multiplying my bases, that's the same thing as if I just simply added the exponents. Now, notice that the base stays the same, just simply adding the exponents. So let's put this in terms with numbers so it actually makes some sense. So if we have 2 to the 5th power times 2 to the 8th power, that's an 8. I don't know why it's not writing very well today. Different pen. Okay, 2 to the 8th, that's the same thing as just saying 2 to the 5 plus 8 would actually be, 2 to the 13th power. Okay, so notice that the base stays the same. I'm just adding the exponents, and it only works when the base is the same. They both have a base of 2. So then let's look at law number 2. This rule is known as a power of a power. So if you already have a base that has an exponent, then you put another exponent on top of that, it's the same thing as if you just said that we are multiplying our exponents. So put this in terms of numbers. So if we have 2 to the 5th power, and then I'm going to raise that again to the 8th power, well, let's think about what these exponents actually mean. That means that I have 8 sets of 5 sets of 2's. That means I have 2 5 times, but then repeat that set of 5 2's a total of 8 more times. So really, that's the same thing as saying 2 to the 5 2 to the 5 times 8 power, which would just be 2 to the 40th. That means I have 40 2's going on there. That's a lot of 2's. Okay, law number 3. What if you have two numbers that are not necessarily the same base, raised to an exponent with the exponent being outside? Just like we do the distributive property whenever we are multiplying, because the exponent is outside of the parentheses, we're going to distribute the exponent. So the exponent is shared with both the A and the B. So let's put this in terms. So now we've got a B. So let's call B 3. All right. So let's say that we have 2 times 3 to the 5th power. Okay, now I know that 2 times 3 is 6, and so we could actually work out this problem and figure out what is the actual value. We could do 6 to the 5th power, and that would be the same thing. But for application in terms of understanding the law, we're going to continue and do the distributive property. So that would be the same thing as saying 2 to the 5th power times 3 to the 5th power. I don't know why my pen's not writing. 3, that's a 3, to the 5th power. Okay, now, like I said, you could actually work that out because these are numbers and they're constant values. You could actually figure out what is 2 to the 5th power times 3 to the 5th power, and that's the same thing as 6 to the 5th power, but at least we're getting an understanding of what the law actually means. It makes more sense when we have variables in these. Okay. Law number 4 is another one of my favorites, similar to law number 1, except instead of multiplying my bases, now I am dividing the bases. And when you divide, your value is getting smaller, so therefore we want the exponents in turn to follow the same pattern, so their exponents will be smaller when we subtract. So if the bases are being divided, then we're now going to subtract the exponents. So let's look at if we had 2 to the 5th power divided by 2 to the 8th power, that would be the same thing as saying 2 to the 5 minus 8, which actually ends up giving us a negative 3, that's a 3. And I actually did that on purpose because there's another law of exponents, you could call it law number 7 if you wanted to, that anytime you have a negative exponent, the negative exponent means do the reciprocal. It's the opposite of wherever the position it is in. So you're doing the reciprocal like you would for a fraction. So I'm actually going to end up making my negative exponent become part of a fraction. So 2 to the negative third actually ends up being 1 over 2 to the third power. Okay, so another way that you could think about it is if you did 2 to the 5th divided by 2 to the 8th, well, that means that you have 5 2's on the numerator and 8 2's in the denominator. Well, which of them has more 2's? Well, of course, the denominator has more than the numerator, so therefore your denominator should stay bigger than the numerator whenever you simplify. There are 3 more 2's in the denominator than there were in the numerator, so that's why I end up with those 3 in the denominator. But anytime you have a negative, I wanted to make that point, a negative means do the reciprocal. So if you have a negative exponent in the numerator of a fraction, bring it to the bottom, make the exponent become a positive. If you happen to have an exponent in the denominator with a negative, which is just mean and evil, and mathematicians do that all the time, just random and crazy. But if you have a negative exponent in the denominator, that means flip it back up to the numerator, and now your exponent would then be a positive. Anytime you have a negative exponent, wherever it may be, if it's in the bottom, bring it to the top. If it's in the top, bring it to the bottom. But make sure that you flip it, do the reciprocal, and change the exponent. It now becomes a positive once you've done the reciprocal. You've taken care of that negative. Okay, and then moving on. So law number 5, similar to law number 3, we're still going to distribute the exponent, even though it's in a fraction, same thing with law number 3 that was being multiplied. So now I'm going to distribute the exponent with both the numerator and the denominator as well. And even if you have multiple numbers or values represented within each numerator or denominator, everything inside the parentheses gets that exponent, just like we do whenever we're doing the distributive property. So if I have 2 over 3 raised to the 5th power, that's the same thing as saying if I have 2 to the 5th divided by 3 to the 5th power also. Okay, and then law number 6, anything to the 0 power is always 1. Anytime that you have an exponent that's a 0, it's as if that number, that term, that letter wasn't even there in the first place. So really, it just represents a 1. Really, you could just ignore it. Anytime that you have anything to the 0 power, it's just 1. So you could just simply cross out anything that is raised to the 0 power. However, be careful, because only exponents that are outside of the parentheses will be distributed and shared with anything that is inside the parentheses. So if you have a 0 outside the parentheses, that means everything inside those parentheses, whatever it may be, anything to the 0 power, that whole thing then becomes a 1. So it's like that wasn't even there. But that is not the same thing as saying if I had 2x to the 0 power, because only the 0 is affecting the x, not the 2, so that would just simply become the 2. It's as if that x wasn't even there. Okay, so those are just a real quick recap over all of the laws. Let's work a couple of examples just to make sure we got it. So if you're looking at 5x to the 6 times 5x to the 6 p squared times 9xp to the third, that's the same thing as 9 times 5 is 45. That's a 45. X to the 6 times another x. Adding them would be x to the 7th. And then p squared times p to the third would end up being p to the 5th power. Again, just adding your exponents there. When the bases multiply, add the exponents. Okay? Example 2. If I have 5a to the 4th, b to the 6th, raised to the 3rd power, that's really telling me that I have 5a to the 4th, b to the 6th represented in 3 different places. So I'm going to distribute the 3rd exponent to everything that is inside those parentheses. That means I have 5 to the 3rd, I have a to the 4th to the 3rd, and b to the 6th to the 3rd. I know, so many exponents. Okay, so 5 to the 3rd, 5 times 5 is 25. 25 times 5 would be 125. A to the 4th to the 3rd, anytime that you have a power, that means we are multiplying those. So then I have a to the 12th. b to the 6 to the third, again, a power of a power. We're going to multiply b to the 18th, and that's my final answer. That's an 8, by the way. Okay, another example with a dividing. So when we're dividing, we're actually now going to subtract the exponents. So let's work out our numbers. We're going to take this one thing at a time. So a negative 8 divided by 2 would be a negative 4. X squared divided by x to the 4th would actually give me x to the negative 2 whenever I subtract, or tells me that I'm going to leave an x squared in the denominator because I have more in the denominator than I have in the numerator. There's only 2 on top, there's 4 on the bottom. Take 2 away, I still have 2 left over in my denominator. And then y to the 3rd divided by y. Well, even though there's not an exponent right here, it's always an understood imaginary 1, just like those invisible coefficients. Anytime you have a variable, there's always an understood exponent with a 1. That doesn't mean 0. So that would be 3 minus 1, which would end up leaving me with y squared in my numerator because I have 3 on top, 1 on the bottom. Take that 1 away, I still have 2 left over in the numerator. So negative 4y squared over x squared is my final answer. All right, so now it's your turn. Here's a couple of practice problems. You might want to pause the video to see if you can do these on your own, and then come back and we will share the answers together. So take a few seconds to work them out, see if you get the same thing I got. Okay, so answer to number 1 should be 40. That's a 4. I don't know why my pen's not writing. 40, there you go. X to the 5th, y, because we have 3 y to the 3rd plus y with a negative 2. So I'm adding with a negative, which actually means I'm subtracting. So anyway, 1y left over. Answer to number 2, you should have gotten 8, r to the 6th, s to the 9th. And then answer for number 3, 6 over 9 reduces to be 2 over 3. And then x squared in the numerator, y squared left in your denominator. So if you got those right, then you are good to go. And then we're going to talk about solving these exponential equations. How do you solve equations with exponents included for our next lesson, our next assignment. So if you have any questions, need any help, make sure that you come by for tutorials before or after school. I hope you've enjoyed. And if you have any questions, just let me know. Thanks. We'll see you next time.